there are sort of things which I'm working on, I've been working on over the summer, which are more blue sky and which are more ambitious. But with a British focus in mind, this is things which I think can be done today. And I think that for some delegates and delegates that are working in education at the moment, that's also relevant. So this talk is called Building a Middle School Curriculum. Apologies again for there's going to be boring words like curriculum and content and stuff like that. Okay, so where do I teach? I teach at Sevenoaks School in Kent, which is an IB school. We teach the IB exclusively. We have done, I think, for over 10 years, and we've taught the IB itself for over 30 years. We like it. We're happy with it as a sixth form qualification. The emphasis on project work we like. The questions seem to have more of an emphasis on forming an argument, of expression, and synoptic questions where the correct method is not signposted. In previous qualifications which I've taught for, there's been hoops that you could quite easily give kids to jump through. What we're less happy with, and this is not just a maths problem, this is across the whole of the middle school, we're not happy with the middle school curriculum. We're not happy with what we're teaching, particularly in year 10, 11, the years going into GCSEs. Okay? We find that the questions are formulaic, they're repetitious, they're the same from year to year, and in maths they tend to be very simplistic, simple answers. The answer to a question is x equals 4. We've looked at different alternatives, and nothing quite fits the bill. So we've actually started our own, or we're hoping to roll out our own Sevenoaks diploma. If you go onto UCAS and you pull down the list of qualifications, there's a Sevenoaks diploma. We're already running this for English literature, moving into creatives next year, and then hopefully geography and some of the humanities will come later. Maths will almost certainly be last because maths has the most amount of conservatism about it, which I might touch on. And when I say conservatism, I mean largely conservatism from parents. That's small c conservatism. Okay, so I'm part of the group that's looking at the middle school curriculum, and I'm looking at mathematics content. So the first question, or the first thing that I want to talk a little bit about is speaking to other subjects. So what have English already done? What are subjects that are implementing the Sevenoaks diploma doing? And if I speak to people in this subject, they talk about something like this, which is as alien to a mathematician as anything I've ever seen in my entire life, but it's very, very pretty. And this is Bloom's taxonomy of learning. And this is the principles by which lots of other people in other subjects have talked about. I mean, I've never come across this when teaching maths. It's sort of been, the sort of mathematical taxonomy tends to be sort of exponents, logarithms, and stuff like this. But they talk about there being these different levels of learning: knowledge, comprehension, applications, analysis, synthesis, and evaluation. And the feeling of the current middle school curricula, or the current GCSEs, is that there's a big focus on the top 2, but less so on the bottom 3. And so in trying to get something which unites what's being done well in other subjects with mathematics, I'm trying to think about ways that we can incorporate some of these ideas. So moving from lower level skills, knowing formulae, what is Pythagoras' theorem, through to sort of the calculating, to the higher level problems, higher level skills. I've never seen on an exam paper a difficult question and then the question is, how would you go about solving? And to form a plan, to form a thought, and not actually to go through all the steps. In a lesson environment, that can be linked to how would you ask, how would you say what you don't quite understand? How would you send an email to an expert so that they could point you in the right direction to solve a question? These are really important skills within problem solving. I've never seen a sort of, well, actually I was very heartened, I shouldn't say that, because there was a question like this on the MAI paper earlier, but questions like summarize your findings, write a conclusion. And most importantly of all, this interpretation, evaluation, what do these results mean? Children seem to have this dissociation between maths and language. It's like chalk and cheese. It's like different class of things. You always shock kids when you say to them, when I was a maths undergraduate, I didn't own a calculator. And, to a maths graduate, it's obvious. Of course you don't. You write arguments. You don't use a calculator, unless you've got a tax return to fill in, but you're a student, so you don't pay any tax, so it's fine. Okay, so how can we move towards these high-level skills? And I think where this ties in with computer-based maths is that I'm very pro-computer-based maths. I think that we've got these wonderful tools. We've got Wolfram Alpha, we've got Mathematica, we've got Wikipedia, which shouldn't be stamped on. The attitude to a problem should not be, right, take this problem and pretend that there aren't any giants whose shoulders you can stand on, and just do it from first principles, do it from the ground up. I point my students towards Wolfram Alpha all the time. Okay? And then they tell their friends about it, and then it's like, oh, isn't it great? We've got this thing that does our homework for us. Isn't that amazing? And then I get letters of complaint from parents in other sets, and they're spending 2 minutes on their maths homework because they're doing it on Wolfram Alpha. Who showed them this horrible thing? Can the school block it? Okay? Now, if we don't change the questions, Wolfram Alpha's terrible. Yeah? It turns a Sudoku into a Sudoku where all the numbers have been filled in. It turns the arithmetic problem earlier from something which is amazing, to which is what you've got if you close your eyes, to something which is, okay, I can see that, that's okay, if you see the answer. But what are meaningful questions in this world? What are meaningful questions where you've got things that can calculate for you? And I've thought quite a lot about this. And what's quite strange and what's quite paradoxical is that the questions that become the best questions, in my opinion, are often the questions that the computers are worst at. Because there's a sense in which you have to find questions which are accessible and which require some thought. This is a question which would be very hard, I think, to put into Mathematica, to put into Wolfram Alpha. If you do it by hand, there's a certain degree of exploration. Okay? It's also a good question. It's a question which I think that everybody in this room could solve. Okay? And I'm not going to spoil the fun and solve it for people. Okay? Where does this question, and it's certainly, and I've tried this on year 7s, I've tried this on 11-year-olds, they play with it, they solve it, it's fine. Where does this question come from? This question comes from the first problem sheet at an introductory course that I taught at Oxford University, and students there struggle. And it is actually, when I say it's an easy question to get the answer, but the answer's not the important thing. The answer is the explanation. Okay? Even if you actually find which numbers are possible, there's lots of little details you need to go through. Why are all the numbers that are possible? Why are the numbers that you're claiming are impossible? Okay? Even if you want to solve this in a computer-based way, there's higher order skills that need to be going on. Okay, I'm not going to spoil the fun again, but if you go onto Google and if you go onto the Wolfram Health pages, you can solve this in one word in Mathematica. Yeah? But you can solve this in one word for Mathematica if you get good at using question mark help. Or if you know the name of the piece of mathematics that this comes from. But if you know the name of the piece of mathematics where this comes from, then you'd become interested and empowered to find out about that piece of mathematics. Okay, it's a good question, but it's fundamentally a very low-tech question. I was very, very proud that I set a question, not exactly this question, but to a girl in my year 7s, and her father writes for The Spectator, and he wrote an article about it, and there was a quote in the article where he says, "I hope this wonderful maths teacher doesn't set any more questions like this, not because I think the questions are too challenging, but I stayed up till 4 o'clock in the morning trying to do it, and I've now started smoking again." And it's finding those things that keep people awake at night, which turns people into mathematicians. It's not the technology. There's a quote which I really like, which says that the day you become a mathematician is the first day when a problem keeps you awake at night. There's another quote which says that links mathematicians to sort of like two rats that are drowning in a vat of milk, and they're sort of trying to tread water and they're trying to stay afloat. And one of them, after sort of several hours, kind of gives up, and the other one keeps going, and then it curdles into cheese, and he just scurries off, or he just eats the cheese, and he has that reward. You plough on at things. So I think the question of computer-based maths is not, we shouldn't focus too much on the computer. We should focus on getting problems that are meaningful. And I think I haven't heard anybody mention the word problem solving and someone from the floor say, oh, we shouldn't have problem solving. If Conrad had wanted to have the least contentious thing in the world and said, what's in CBM, if he said problem solving, we'd all agree. So let's go look a little bit about what things might change to lead to a more CBM approach. One of the things which I think is really artificial in education at the moment is this standard model. When people come to choose their A-levels, when people come to choose their GCSEs, there's a segmentation into different subjects. Can you do maths? Should you do physics? And this provokes a very decontextualized approach towards the subject. So a lot of the problems that you would talk about in doing in terms of CBM would be hard to implement in a classroom because you can't assume everyone would know the physics, or you can't assume that everybody would know the different subjects. So that's one of the sort of meta reasons why I think we've led towards a decontextualized mathematics and a very abstract mathematics. And again, what we're all shouting for is concreteness. What we're trying to do with the middle school curriculum is we're trying to form a curriculum map. We're trying to form not a distinction into subjects, but something which is linked together into a sort of holistic whole. This is the IB diagram, which shapes a lot of what the IB does. And at the center of it, there's the IB learner profile. That's what you're like as an individual. But then there's this whole sort of synoptic subject, the theory of knowledge, right at the heart of it. That's where you're meant to reflect on the different skills. Now, if you were to say, where should CBM fit? Where should computer-based maths fit? Where should maths fit? My conjecture is that it should sit right in the middle. It should be the bridge that links the other subjects, together. Because otherwise, you're having to introduce the problem. You're going to have to make up the problem. But kids are already, when you look at this problem, where are kids learning statistics? They're learning statistics well in geography. But what they're not doing in geography is they're not linking it back to what they're learning in maths. How many year 10 students could recognise what a population pyramid was showing about a country? All of them. Yeah? How many of them could plot a histogram? Yeah, some of them, but they might struggle. How many of them could spot that it was the same object? Very, very few. And I think one thing that we really overestimate about students is this ability to form links. Links which are obvious to us, and links which are particularly obvious to us as mathematicians, they struggle with. And there's all sorts of research that backs this up. And I think if there's one book that I would recommend, alongside, a lot of the stuff that we've talked about CBM, is I think this book, Making Learning Visible, is absolutely pivotal. Because what it says is that we need to keep telling students why they're doing it, what they're doing it for. Otherwise, every maths teacher wakes up in the middle of the night with questions like, just thinks back to all the students that asked them, why will this be useful in later life? What is the point? And what we've seen in lots of these discussions is that kids are energized, they are effective learners, and they do amazing things when they can see the point. So what's happening within 7 Oaks? So this is going to, as I say, it's going to be rather parochial, because there are big projects, there are things that I've that I've looked at, but what I've found in school teaching is sometimes you can achieve enormous amount in 5 days. You can look at an RI course where kids are doing, programming sort of Lego robotics, and they come out with a deep understanding. And then kids can learn very little in 5 months. Now, is it possible just to graft those 5-day learning experiences into a school environment? Is it, the young rewired state, teen tech, all those things are fantastic, but, could you have a consistent diet of that within schools? Now, ideally, yes, but then practically, if I tried to teach, I'd love to try and teach y equals mx plus c by getting that drone, programming something in Mathematica, getting it to fly around the classroom. I'd be knackered. By the end of the week, I would just be in pieces. By the end of the month, I don't think I could continue. Also, because what happens if the drone flies into the wall and crashes onto the floor, just the practicalities of the classroom, everyone here sort of nervously laughed. Teenagers would find it, would find it hilarious. The whole thing could break down. It's very, very difficult to have a CBM approach the whole time. So I'm going to talk about very little things that are being done and seeing what I think we gain from them. So firstly, collaborations with other subjects. Okay, if we sort of say what's in and what's out of the maths curriculum, then I think sometimes we can get lost within our own subject and realise that some things are actually cross-curricular. So already within 7 Oaks, we've got things in place where when the English department look at text, that they're looking at text with numerical content. They're looking at the link between styles and numbers. This was prompted by a talk where David Spiegelhalter came and gave a talk to the students. And at one point he said, oh, most journalists, they use numbers like adjectives. And it's kind of true. And what we need people who are tuned into looking at how adjectives work to looking at how numbers work. And this whole thing of quantitative literacy, this was an article in the last couple of days. I mean, I don't know whether there's any sort of statistical significance that it was in the Daily Mail, but it was picked from the Daily Mail. Needless cancer therapy for 4,000 women. For every life saved by breast cancer, 3 patients undergo unnecessary surgery. How do we analyse that? How do we make any sense of that? In the IB world, that would be analysed within theory of knowledge. And it would be analysed, I think, probably better within theory of knowledge than by a calculation. And what we're doing in Sevenoaks is we're trying to get the English department to look at stuff like this, because we can't do all of CBM in the timetable available to CBM content. Collaboration with geography. This is going to start straight after half term, where we team teach. We make sure that we teach statistics, histograms, cumulative frequency graphs, bar charts, pie charts, all those sort of things at the same time that they're learning human development indexes within their geographical studies. So, and actually look at what each subject is teaching. So the geography teacher can say, you'll recognise this as a histogram, and vice versa. And once the middle school curriculum kicks in, we're looking at things like jointly assessed projects, where they do their statistics project in geography, but they're also marked on their the statistical content, and it's marked by the people who know about it. Which makes it realistic, right? Because my wife's a neuroscientist, but I can't analyse her data because I don't know what it means. Electives are important. I think we've seen that the students are energised when they've got their own choices. And this is the deployment. So this is what we've already achieved. Stuff that's in development. But I think the future is a CBM qualification, and that would be a cross-curricular CBM qualification. There's lots of discussion, should we call it computer-based maths? Should we call it math-based computing? At the end of the day, I think what we should really have is education, and we should just have one subject that's just called stuff. Thank you very much.